Good afternoon. My name is Natasha Oyedelli, and I want to welcome you to the NIH Office of Disease Prevention's Methods Mind the Gap webinar series. This series explores research design, measurement, intervention, and data analysis, and other methods of interest to prevention science. Our goal is to engage the prevention research community in thought-provoking discussions to promote the use of the best available methods and to support the development of better methods. Before we begin, I have some housekeeping items. You can submit questions during the webinar by clicking on the question mark in the WebEx toolbar. Please direct your questions to all panelists. We will open the floor to questions that have been submitted via WebEx at the conclusion of today's talk. The slides and video recording will be posted on our website, prevention.nih.gov/mindthegap in approximately 1 week. You will receive an email when they are available. Lastly, we would appreciate your feedback about today's webinar. Upon closing the WebEx meeting, you will be prompted to complete an evaluation. We would appreciate your feedback as it will help us improve this webinar series. At this time, I would like to introduce Dr. David M. Murray, Associate Director for Prevention and the Director of the Office of Disease Prevention.
Thank you, Natasha. Today's speaker is James Wagner. Dr. Wagner is a Research Associate Professor at the University of Michigan's Survey Research Center. His research is in the area of survey non-response, including indicators for the risk of non-response bias and adaptive responsive survey design. He's the co-author of a new book entitled Adaptive Survey Design. He has published articles in a variety of journals, including Public Opinion Quarterly, Statistics in Medicine, the Journal of the Royal Statistical Society, Journal of Official Statistics, and others. Dr. Wagner is also the Associate Director for the Michigan Program in Survey Methodology. He teaches courses on sampling, statistics, and research design. It is my great pleasure to welcome Dr. James Wagner.
Well, thank you, Dr. Murray, and thanks to the NIH Office of Disease Prevention. I'm excited to be here today to talk about responsive and adaptive survey design techniques. The title of the talk is Improving the Efficiency of Prevention Research Using Responsive and Adaptive Survey Design Techniques. And you can see my contact information here. And I'm happy to answer questions, so I'm giving you my email address. You know, as Dr. Murray said, I'm a Research Associate Professor at the Survey Research Center. Here's some additional information about me. I'm also co-PI of an NIH R25 funded research education program. And I'm giving the website here. And that research program is focused on responsive design. And so we offer a number of webinars that are more detailed than the discussion I'll be able to give today. I'm going to start with an overview. I'm going to give some background about the changes in the social research environment that led to the development of the class of techniques we've labeled responsive survey design, and sort of answer the question, why do we need this? What does it do for us? And then I'm going to talk about some of the basic concepts of RSD and define some of the key terms. I'm going to use that information then to start to talk about the steps and the tools for implementing a responsive survey design in practice. And I'm going to give examples because I think that helps make the discussion concrete. So the examples are limited. I can't do very much in the amount of time that we have in terms of examples, but I want to give some, and I'm going to focus on a single survey that's longitudinal in nature, and I think will be most relevant for this audience. We have other examples, but I chose this one to focus on. So as I said, I want to start with this question, why responsive survey design? Why do we need these class techniques? And I think the answer has to do with really, I'd say, broad changes in society that led to uncertainty in data collection. So over the years, non-response has been increasing for surveys and survey-like data collections, including clinical studies. It could be attrition, a process of people leaving a longitudinal study, or it can be that people fail to participate at the beginning or when we request even for a one-time survey. So that increasing non-response has negative consequences for us. That can lead to biases. I'll talk about that more later. But the most immediate consequence is increase the cost of data collection. You might see the connection because If it becomes difficult to recruit, we try more things. We put in more effort. We make our designs more complex, all trying to accommodate the fact that response rates are falling, and that leads to increasing costs. Now that sort of has cut the ground out from underneath us. I'm going to talk about uncertainty here, but I think I want to start with a little contrast about how we used to field surveys. And I started working on surveys in the 90s, and the experience that I had was we would design the survey ahead of time. I worked on a lot of telephone surveys. We expected we'd get about a 70% response rate. We knew how much sample we needed to get the required number of interviews. We knew how much effort it would take. We put it into the field, and then 2 months later, 3 months later, whatever the specified time period was, the results came back pretty much as expected. But we started experiencing difficulties in the early 2000s and maybe earlier where the design wasn't turning out in the way we expected. And we had to make changes. We had often have these kind of emergency meetings where we're talking about ad hoc changes to the survey to account for things that we hadn't foreseen. Okay? So that is the uncertainty that developed over time, and it's partially due to rising non-response rates. And now we need more complicated designs to try and counter that. And there's also variability in data collection that means outcomes are uncertain. Here's just an example that comes from a nice overview paper that took a look at patterns in non-response over time. I'm showing a figure that you could think of as an example. This is 6 or 7 major national face-to-face surveys that are conducted almost annually. And you can see the pattern is generally declining response rates over the period we see in this figure. So roughly from 2000 to 2014, many of these very prominent surveys, you may be familiar with the National Health Interview Survey, which is the red box, or the National Health and Nutrition Examination Survey. Very important surveys that have been experiencing decreasing response rates over time. I could show you from the same paper decreasing response rates to telephone surveys. I could show you decreasing response rates to web surveys, right? So it's not that it's specific to large face-to-face surveys. It's just an example that I'm showing. It demonstrates the point that something was changing. We're not exactly sure. We don't have an experiment. We haven't run dual societies to see how response rates might be different depending on social characteristics. But we suspect it has something to do with changes in society. Well, a related issue, which I alluded to earlier, is increasing costs of data collection, which is related to the greater difficulty in gaining participation. So if response rates fall, an immediate response might be, well, let's make more attempts. If we're on the telephone, we'll make more contact attempts. If we're running a web survey, we're going to send more messages asking for participation. If we're running a panel survey, if we're contacting people wave after wave, we might spend more time trying to locate people who have moved or who are difficult to find. Well, I'm using as an example here a survey that's conducted on a monthly basis since 1978 by the University of Michigan. That survey has experienced declining response rates over the last period of time, and one response was to increase the effort. And I'll show you a slide that kind of makes this point on the next slide. But a lot of this is the costs that are related to sampling and mode-related factors. So for instance, we've adopted web modes as the less expensive mode, but that particular mode has required more expensive follow-up procedures in order to produce higher response rates. So there are these challenges that we're facing that have made costs go up. So here's an example from that same paper, that same sort of review paper where I showed the declining response rates. They also looked at how effort was increasing at the same time that response rates are declining. So even with this extra effort, it didn't make up the difference, right? It didn't put response rates back to where they were. So it's sort of fighting a losing battle. And you can see steep curves going up after 2006. And all that means is we're spending more effort and we're still not getting the response rates that we were getting before. So you can understand why this would drive costs up. So that might raise a question for you. Why does this matter for longitudinal prevention research? And I alluded to this a little bit earlier, but we're concerned that this kind of rising non-response can lead to biased estimates. And in the context of prevention research, that could mean biased estimates of treatment effects, especially if we have some kind of treatment we're trying to judge in a clinical trial or a comparative study where we have an experimental study where we have two different treatments and we want to compare the two. If the attrition is differential across the arms, then we may have biased estimates of the treatment effect. Or if people are leaving longitudinal studies before they are complete, then we may have biased estimates of long-term benefits, the benefits that don't accrue or don't show up until close to the end of the data collection period. If neither of those are a problem, then it can still create this problem of increased standard errors, which leads to a reduction in the planned statistical power, right? So if we had planned to get 1,000 interviews or collect observations from 1,000 persons and we only get 800, we've got a problem, or a potential problem. And of course, we've already talked about increasing study costs. When we're trying to combat these non-response issues, it can lead to more effort and higher costs. So as I said earlier, when I talked about how in the past, we would plan the design ahead of time. We thought it would go pretty much as it planned. And then when it didn't go as planned, we had these ad hoc decision-making processes where we would say, oh my gosh, what can we do? What's available? And we usually ended up with something less than optimal. We also were creating procedures that were difficult to replicate. So one of the principal aims of this new methodology we're proposing is to address these problems during data collection in a planned and principled way. And we're labeling the approach as responsive survey design. Okay, so that's the background. That's sort of the why. Why would we want to look at this? That's the situation that we find ourselves in, and this is a response to that situation. I'm going to take a little time now to try and define responsive survey design. I'm going to give a kind of an overview, and then I'm going to run us through some concepts that are critical for understanding that overview. And then I'll try to make it more concrete with some examples, okay? So the origins of this go back to some works from some colleagues at the University of Michigan, Bob Gross and Steve Haringa, who published a paper in 2006 that said, hey, responsive survey design is a class of technique, and these are the principal steps, the principal components of a responsive design. So the citation is at the end of my slides. If you want to go and read the paper, you're welcome to do so. I'm going to give a quick overview. They have four main concepts. The first is pre-identify a set of design features that affect costs and errors. All right, so in survey methodology, we're often considering decisions as cost-error trade-offs. Can I reduce sampling error by increasing my spending on interviews? Can I reduce the risk of non-response error by spending more to recruit non-respondents into my study? So those are the kind of trade-offs that we're considering, and thinking about how my design is going to be impacted by different costs and errors is an important part of a responsive survey design. Once you've done that, identify a set of indicators of the cost and error properties of the features of your design and monitor those. Watch what's happening. So this is where we're combating the uncertainty. So instead of predicting what's going to happen before we start, we're going to monitor what's happening while it's happening, right? And one thing I'll say is that computerization has really helped us here. So in the past, when we were doing those face-to-face surveys I talked about, we didn't use computers. We used U.S. mail to send back and forth information about what was happening in the field. So it was much more difficult to know where we were at any moment. Now with computerization, we can know what's happening at any given moment for virtually any kind of survey we do, telephone, mail, face-to-face. So we can monitor indicators, which leads to that third component. I'm going to alter the features of the survey in subsequent phases based on these cost-error trade-off decision rules that I pre-specify. Okay? So that might seem a little vague, but I'm going to give some examples that I think will help clarify what we mean. And then the last step is to combine the data from different phases, from different combinations of design features to produce quality estimates. Okay, so keep that overview in mind. Let me define some key concepts. I'll just take a few minutes to define these key concepts, and then we can turn to some examples that I think will help tie everything together. The terms I want to define are just design phase. I'm going to talk about complementary design features. I'm going to talk about the use of experiments in early phases. I'm going to describe the notion of phase capacity. I'm going to talk about paradata and how we use it in phase evaluation. And I'm going to talk about error-sensitive indicators. So the first term that I used just now is design phase. And it's related to this notion that comes from some folks at the Census Bureau in 1961. Anson, Hurwitz, and Burchard, they said, we could think of surveys as having a set of essential survey conditions. And I think today we might use the words, these are the design features that I really need to make other people aware of if they want to reproduce the research that I've done. What are the most important features? So the names of the particular interviewers I used wouldn't necessarily be essential survey conditions. But the fact that I'm using interviewers is an important part of the survey. A design phase includes a particular set of design features that are fixed for some part of the data collection. I'm not just I can't say the time, as I talk about phases, they don't necessarily correspond with time. Sometimes they do, but sometimes they don't. So that's what's described in the third bullet here. Phases can be sequential, that is, the first month is phase 1, the second month is phase 2, and the third month is phase 3, and so on. Or they can be concurrent. So that is, if I have a rule that says cases are going to be switched when some event occurs with that case, then I can be in different phases at the same time. Right? Now, I'm not using this term phase to mean what I would call a wave in a longitudinal data collection. So a wave might mean I'm going to collect 3 observations on the same person. I'm going to have 3 waves. I'm talking about phases within the same data collection period, within the same wave, if you will. So that's design phase. It's an important concept. And I want to give an example here. Simple example, I'll come back to it again. 2-phase survey. In the first phase, I'm going to do a web. I'm going to invite people to participate in a web survey. And in the second phase, I'm going to use a telephone to attempt to complete the interviews that were not completed in phase 1. Okay, so a follow-up phase. And I'm specifying it a little more here because sometimes I think, well, when people say web survey, they think they've said it all, but in fact, there's a lot of features of web surveys that need to be defined if I really want to tell you what the essential features of that particular phase are. So here I've said, I'm going to send up to 3 email invitations. I have a 15-minute instrument that's completed over the internet. And in my telephone phase, I'm going to use up to 8 contact attempts and complete that same 15-minute instrument over the telephone. Okay, so there's other features I'm not mentioning, but that gives you a sense of, yes, there's a set of essential features that define the phase. And the major difference in this case is the web and telephone features. The third concept that I wanted to define is complementary design features. And the idea here is that when I'm combining across the phases, I'm going to minimize the error across all phases. So the first phase might create one kind of error that's balanced by what I do in the second phase. That sounds pretty abstract. Let's take a look at that same example, but here I'm going to try to describe how these 2 phases might be complementary. Totally made up example. I'm not saying that this is empirical. I'm just making up an example here that says in phase 1, what if that phase was more likely to recruit younger persons and persons with internet access? Well, phase 1 by itself is biased, right? It tends to exclude older persons and persons who do not have internet access. Phase 2, on the other hand, might attract older persons and persons without internet access. Again, phase 2 by itself looks like it might be biased, doesn't represent the younger part of the population very well, and certainly doesn't access persons with internet as easily as the web survey does. But when I put those two phases together, it's possible that those deficiencies of each might complement each other and create a kind of a balance, where I've created a representative group through my recruitment protocol. So that's the idea of a complementary design feature. A fourth concept is the use of experiments in initial phases. So a lot of times when we're looking at these designs, when we're designing a new survey, we don't know anything about the population, maybe it's a new topic. It's often difficult to know what design features make sense in any particular setting. Or to answer the question, which set of design features is optimal, or which set of design features are complementary in the sense I just defined. Well, one approach is to use a part of the sample, maybe a random subset of the sample, to experiment with and try at least a small set of design features, to vary experimentally a small set of design features across those cases to see what may work, and maybe even to learn, are there design features that are complementary? So these randomized experiments allow for database decisions in the context of the specific study. So that's one of our goals. I'll come back to tie that notion together if it seems a little vague at the moment, but I'm going to tie this all together in the next few slides. Another concept I want to elucidate, this is a quote directly from the Groves and Haringa paper, has to do with phase capacity. So there's the definition which you can read, but the main point is to say a phase reaches its capacity when further recruitment under that design does not change your estimates. So think about the example I gave a moment ago where I said I was using that web survey and maybe I'm recruiting younger persons. If I'm only recruiting younger persons, if my estimate stabilizes, it's not helping me in terms of any potential biases that might occur. Now, of course, it helps reduce sampling error, but if I'm not reaching that older part of the population that I want to, then maybe I've reached my capacity. I'm not going to learn anything additional from running the current phase, and it's time to switch to a new phase. That's the idea of phase capacity. So when the slide says there's no benefit to additional effort, it's really saying in terms of representing the population. We're just getting more of the same. That's phase capacity. Well, I used a term earlier, which I didn't define, and I'll define it now, paradata. Paradata are data about the data collection process, and I'll give you a couple of examples you may or may not have seen before. We use something, we call them call records. Other people call them records of contact attempts. The Census Bureau has something called the Contact History Instrument. They call it the CHI, and that's a system that records the history of how many times we've tried to contact a sampled unit, what happened, did we talk to somebody, did we not talk to somebody, and so forth. Did we try different times of day, etc. And that's the way that we keep track of what's happening in the field. You remember I talked about computerization a minute ago. Well, now essentially these records are all electronic, they're computerized. And we can know at any given moment what's the history and current status of sampled units. And those paradata then are beneficial to inform us about what's happening and to monitor what's happening. The second example is one that's relevant for measurement problems that can occur in surveys, and I'll come back to that in a moment, but that's the idea of keystrokes. From a web survey, I use a couple of acronyms from our field, CADI, that's computer-assisted telephone interviewing, computer-assisted personal interviewing. Really, it's just telephone and face-to-face interviewing, but those computerized systems give us information about what's happening in the field within the instrument. Are there problems occurring? Are there things that would need to be addressed while we're in the field? Now, these paradata can be used to form indicators. So for example, we could answer questions like, do estimates change when we make the 10 contact attempts compared to 8 attempts? It's a very simple way of looking at phase capacity that I talked about a minute ago. I can use paradata to help me answer those kinds of questions. And we can convert those into error-sensitive indicators, right? Now, one of the problems we have with a problem like non-response is that we don't know what the non-respondents would have said. I mean, we wouldn't be doing a survey if we already knew what people were going to say. And when we don't have the opportunity to get their responses, we can't be certain what they would have said. So we have no way to say what the non-response bias was. We can only evaluate through proxy approaches. And this slide really just defines one proxy approach that's become quite popular with survey methodologists. It's called an R indicator, and there's a citation here. In the simplest of terms, what the R indicator does is look at the variability of response rates across subgroups in the population. And we judge more variability to be bad. Why is that? Well, more variability indicates that some subgroups are responding at much higher rates and others at lower rates, which could be evidence of some kind of selectivity in our protocol. If you think of the examples I gave earlier, if we saw that younger persons had much higher response rates than older persons, we might be concerned that our estimates are biased by some mechanism related to non-response. Excuse me. So a possible indicator for the risk of non-response bias is this R indicator. Subgroup response rates are another potential indicator, proxy indicator, as is a response rate, a proxy indicator. But all of these things can be useful. And in the case of an experimental study, computing within treatment groups may help us understand if the initial randomization is held up over time. In other words, do the people who are responding to our requests for data look like the people from whom we requested that data, the full sample? Do the respondents look like the full sample? Well, here's a chart that I think ties this together, and I took this from the original 2006 paper. It divides the data collection into three periods, three phases. And in that first phase, they're running experiments. There's options 1 through little n. That just makes this notation generic. It doesn't mean you have to run an infinite number of experiments. I think 3 experiments on 3 different design features is the most I've ever done. But the idea is to genericize the approach, that we run some experiments because there is a lack of information early, and we can learn from those experiments. And in this case, maybe what we've learned is that design option S is low cost, and we successfully recruit in phase 2 with design option S. But we found that design option T is complementary to that option, and so we run that as a follow-up protocol with those who don't respond under design option S. Okay, so we hope that those 2 phases are complementary, and we've used that experimental period to identify those complementary features. Along the bottom, you'll see, so if you think of it, phases as going across time, along the bottom, you'll see the process data assessment. That's looking at pair data, monitoring indicators, and also real-time estimation of key survey statistics. So then we can see, does design option S stop changing estimates? Should we switch to design option T? Helps us answer those kind of questions. Okay, so those are the concepts that I wanted to define. Now I'm going to look at this as a process and use an example survey and say these are the steps used to implement this responsive survey design. It's an example. We have others. I'm happy to share others if you have interest that particular kinds of surveys, and the survey I'm talking about is not a good example for the kind of work that you do. Just let me know. I'll be happy to share other kinds of examples. But the example I'm drawing from I thought was most relevant because it's a longitudinal study that we did a few years ago where we collected data, a weekly survey for 100 weeks. And the name of the survey was the Relationship Dynamics and Social Life Panel Study. It documented risk factors for unintended pregnancy and early adulthood. So we sampled about 1,000 women ages 18 to 20 in a single county in Michigan. and then measured weekly dynamics of contraceptive use as young women enter and exit sexual relationships. So I'm not a demographer. We had demographers on the team, but these were the questions that they wanted to answer. And they wanted to minimize recall error in order to maximize the accuracy of the relationship context of contraceptive choices. So the idea is it's difficult to remember why you made the choices you did about contraception 2 years later. If I come to you 2 years later and ask you about contraception 2 years ago, it's going to be difficult to answer those questions. And in fact, you may misremember what happened. And so asking at the time was a way to address the kind of errors that can occur because of that long distance recall. So we conducted weekly interviews, and we went for 30 months or 130 weeks. It's actually the same. You do the math, 130 weeks and 30 months. We wanted to get 130 surveys from each of about 1,000 women. Now, when we started, we said, we know some people aren't going to have the internet, so maybe what we'll do is we'll have laptops and we can give them laptops, or maybe we'll have phone interviewers who will contact these women once a week to complete the surveys. We weren't sure. We were going to experiment with options, including allowing women to choose more than one mode. Now, honestly, we had kind of hoped that most people would choose the internet, that they would use the internet every week. That would be how the majority of the data were collected. But we allowed that that might not work. And we had plans to try and other modes to keep people involved in the protocol. And one other thing I should say, it was a single county in Michigan, and so we did face-to-face interviews where we achieved high response rates. We conducted a baseline interview, that is, our interviewer interviewed the selected young woman and then turned the interviewer's laptop over to the young woman and said, here, you can complete your first weekly journal. And then we left, and the goal was to keep that person involved for 129 additional weeks. Okay. So what are the steps to thinking about implementing a responsive survey design? I'm going to use the example. But the first step, here I've labeled it 0 because I didn't really talk about it before. Here I think because things like non-response bias aren't directly measurable, we have to set priorities. We have to set objectives. We can't just try to minimize error or maximize quality. That's too vague. We need to define what the key objectives are, or we can flip that on its head and say, what are the biggest risks that my project faces? Okay? So Groves and Herring, I don't really talk about this, but we've made this a part of our program to say, hey, you need to think about what your objective is. Are you trying to limit the risk of non-response bias? Are you trying to make sure that you're controlling your budget so that you do not go beyond a fixed budget? We think it's important to make explicit the prioritization of objectives. In the case of the RDSL, we had two top priorities. One was to minimize attrition from the panel. That is, to prevent young women from dropping out of the panel. And our next priority was to complete as many weekly interviews as possible. So we wanted 130. And the problem was we were only going to ask women about their experiences in the last week or 2 weeks. So if somebody missed 2 journals, we were going to start missing data. We were going to be losing data. We weren't going to have complete observations. So keeping people involved on a regular basis was a high priority. Okay. The next step, here we're calling it step 1, is to identify areas of uncertainty, which I said before. Survey design, we often assume that the quantities are known ahead of time, like response rates and how much it's going to cost to get an interview, that sort of thing. But these estimates actually have uncertainty. And so identifying those risks, which most threaten the quality of estimates, in particular treatment effects, is an important step. And knowing what those uncertainties are. Here's some examples. We could be uncertain about sampling error. Are we going to be able to get a sufficient number of interviews? Non-response error, we've talked a bit about. Am I going to have biased estimates? Measurement error, maybe we haven't said so much about, but we know, for instance, that interviewers introduce variance into estimates. They introduce noise because they're a measurement tool, and when you have many measurement tools, they may differ. and that introduces noise into our measurement. The mode itself can have an impact, and here we mention this term social desirability bias. So in many studies, it's been demonstrated that the presence of an interviewer can change how people respond to questions. They may edit their response in a way that they feel is socially desirable to make their answer more socially desirable, because the presence of the interviewer makes it difficult to give an unedited response to a sensitive question. So measurement error can be an issue. And you might want to think about the kind of risks that your projects have faced. What were those biggest risks? In our example study, we had these 3 risks, among others. I mean, I'm simplifying the problem, of course, but sampled women not being willing to participate. What could we do to get them to participate? The second risk is that panel members begin participating but stop. We call that attrition. They drop out. We don't observe them again. We did not get 130 observations. And the third risk I alluded to a moment ago, which is they participate rarely. That is, if they skip more than 2 weeks without providing a completed journal for us, we're going to have missing data. We're going to have parts of their history that we're not going to record in our data. It'll be missing. So once I have those risks outlined, then I can start to talk about indicators. And here I'm showing a more complicated chart that shows all the different risks that we identify in the survey process. On one side, you see measurement problems, and on the other side, you see representation problems. So measurement error is the kind of the social desirability thing I was just talking about, and representation is like that non-response problem. But there's other sorts of errors that can occur in this process. Here I'm just focusing on the red box. I can use contact data and interviewer observations, so those call record information, to say who's responded and who hasn't responded at any given moment. And what are the characteristics of those who have responded compared to those who have not responded, the sample. I talked about keystrokes earlier. On the measurement side, I could take a look at keystrokes and say, are some questions taking more time? Are people backing up? Are they changing their response? Are they hitting errors in the questionnaire that indicate that there may be problems in the question? That is, measurement tool and the response aren't working properly, that we're not getting reliable measurements of the concepts we're after. So that's just examples of how Paradata could be used to form indicators. Now, very simple indicators were really all we needed for the risks that I identified in our example study a moment ago. So the first risk, not willing to participate, we could look at the percent who completed web survey number 2, right? Remember, web survey number 1 was completed with the interviewer right there helping them. Web survey number 2, they needed to do on their own, and we felt that that first interview they did on their own was important, and we needed to know if somebody didn't complete that within 7 days. And we designed an intervention that I'll talk about in a moment to address that. We also wanted to know a slightly different statistic. That's the percent who stopped completing web surveys. So we monitored after 3 months, after 6 months, after 9 months, right? How many people have stopped completing those web surveys? And can we try to do something to bring them back in? And then again, a third slightly different indicator, all have to do with attrition or non-response, but this one is if they miss a survey after 14 days, can we remind them to get them to start taking up their journals again? Okay, so some people had kind of intermittent. Maybe they could participate monthly, and we want them to participate at least every 2 weeks. So those are the error indicators. The examples, we'll come back to these same examples when I talk about interventions, but here's just a definition of an intervention. Maybe it seems silly, but we think of there's 2 components to an intervention. In our responsive survey design context, the first is a rule that specifies when you're going to take that action. So if a subgroup response rate is more than X% below the next lowest group, take an action. And then what is the action you're going to take? Now, ideally, interventions are going to coincide with the boundaries defined by phase capacity. Okay, so it's time to switch when the phase capacity is met. When I'm not getting anything new, I'm just getting more of the same. Ideally, the intervention introduces complementary design features. Okay, so when I'm only getting more of the same, I switch my design, I intervene, and I start to get something different. That's the approach. In our example, we use the experience of early replicates, those are just random subsamples of the full sample, to experiment. And we discovered that we needed multiple modes of reminders, and we also needed to allow people to conduct their weekly journals in multiple modes. That is, we couldn't force people to just use the web every week for 130 weeks. Many of the respondents found it necessary or helpful to respond via the telephone over the time period. So we created a couple of rules. If the second interview is not complete after 7 days, start the email reminder protocol. And if the previous interview is not complete after 14 days, we started a more aggressive telephone reminder protocol. Now, just a quick word on that. What we found was that 872 of our 947 respondents said they wanted to do the survey on the web each week, but 60% of those 872 had to use the telephone at some point to complete their journals. And a similar thing happened among the small number of cases that wanted to use the telephone. Right? So it's important that we offer this mode switching option. I'll come back to the results in a moment. That's the last step. Now, before I said you got to make estimates. You got to combine data across the phases to make estimates. Here I'm going to say not only make estimates, but evaluate and document what happened. This is an important part of the process. And we need to, I think our goal should be replicability so that others could follow similar procedures. Now, here's the results I mentioned. In this table, I'm showing 3 columns. The first is the total sample, 947 persons. In the second column, it's the subsample who used the same mode at every journal, the 504. And the third column is that switchers, persons who use 2 modes. And I think across all of these items that were measured across the 130 weeks, we found differences between people who stayed in a single mode and people who switched. And we use this as some evidence to say that, well, it looks like if you allow people to switch, you're going to have a better outcome. You're going to be able to recruit different kinds of people and get different responses. So those are static concepts, events that occurred in 130 weeks. But we were interested in kind of a survival analysis approach where we used logistic regression, discrete time hazard models to look at the hazard of pregnancy. And here we're just comparing some of the coefficients in the model. We're not showing everything. The desire to become pregnant and the desire to avoid pregnancy and their relationship to the hazard of pregnancy. And on the left-hand column, is the full sample. And on the right hand is a subsample where we didn't allow any mode switching. And you'll see that there's differences in the estimates, not in the signs and not very significant difference between the coefficients, but it does make a difference in the statistical significance. So taken together, we take that as evidence that the approach was able to recruit successfully and in a complementary fashion. So at the end, just a real quick summary, the responsive survey design arose in the face of uncertainty about key design parameters, in particular, rising non-response rates. We like to emphasize that it's a pre-planned procedure where we have rules that are specified that triggered interventions or phase changes. And it's a framework for optimizing decisions that should lead to replicable research. I'm open for questions now. I'd also like to say, feel free to contact me again. Here's my email address after the webinar if you have questions, or I think if there are unanswered questions this afternoon, I'll try to answer those as well. So thank you.
I thank you very much, Dr. Wagner. Very interesting presentation, and we have a number of questions to consider for you. Just some nuts and bolts things maybe to start. What sort of software do you use when you're collecting paradata or information on these indicators? How does that work?
Well, that can work in a number of different ways. We are survey professionals. We are a large organization that conducts surveys. We're not the largest, but we've written our own software that allows us to keep track of the information about emails, text messages, face-to-face attempts, and so forth. We've also worked with people who've used relatively simple systems in order to do that. You know, Microsoft databases, Excel spreadsheets as a way to track what's happening. I think the key thing is that we can transmit that information back and forth, that we can create a centralized database of that kind of information. Now, many interviewing software systems also can provide information about how long did it take to answer that question. Did the person who responded to that question change their response? It's possible in web surveys to gather the same kind of information, right? That if somebody's completing the survey on the web, we can get information back about keystrokes, time in different fields, and so forth. All of that information can be helpful. And I just want to say that it doesn't take super advanced technical systems to do those things. Certainly helps, but it is possible to do with what I would call low-tech solutions.
The process that you described requires a lot of planning, a lot of thought in advance about how you're going to do all of this, and very much in parallel with the kind of thing that's required if you're going to do a smart trial and adapt your intervention as things go along based on the experience that you're having with it. So it's not an unfamiliar process to people that have worked on intervention trials and considered adaptive design. This is very much the same kind of thing, but it's for survey data collection. So very interesting to think about the parallels. You've given us a number of examples of design options that might be useful, of indicators that might be useful, but I suspect that those are going to depend very much on the nature of the survey, the nature of the target population, the setting. Is that true? Are there design features, indicators that are common across surveys, across survey projects?
Yeah, I think that's true. So a lot can depend on the population. So for instance, we've been conducting surveys of students. Students are a very nice population to study because we can develop sampling frames from which we can select random samples with many known characteristics. We have really good contact information for those students. We have their email addresses, which is often very important if we want to conduct a web survey. And in that environment, and students are actually accustomed to taking surveys. So in that environment, we have different options than if we are going to conduct a general population survey, let's say of persons living in households who are 18 years of age and older. Now, in that case, part of our population are people who do not even have internet access. And so we've got to ask the question, how are we going to deal with that part of the population? Is it important enough that if we exclude it, our estimates could be biased? And if we don't know, then we have to have some way to appraise the risk of that, what we would call coverage bias, if we don't even include them in our survey. So a lot does depend upon sort of the population. A lot can depend on the topic of the survey. So different topics, it's been shown that the topic of the survey itself is a kind of inducement for some people. So if you do a survey, in a famous example, somebody sampled from a list of bird watchers and then gave them a survey about birds and had very high response rates. They gave the same survey about birds to the general population and had very low response rates. Okay, so that topic can play a role, and it's often difficult when you're dealing with specialized populations because you're not going to have someone else's experience to lean on. Or maybe very difficult to lean on someone else's experience when you add in the 5 other factors that you have that are specific to your design. So a lot does hang on what's the population, what are you studying, and what options do you have to implement that design?
You told us that one of the important things to do was try to structure your phases so that when you combine them, you're going to end up with good balance. How do you know what that balance should be, and how do you know when you've achieved it?
Yeah, that's a great question. The first thing I'll say is we don't know for sure. Right? Remember I said non-response bias. If we knew what the non-responders would have said, life would be easy, but we almost never do. So we've adopted an approach of using proxy indicators. And often that's a useful approach where we can say, are the characteristics of the respondent set closer to the sample, at least along the dimensions we can observe, after we use this second phase? Are the characteristics drawn closer by the addition of this new phase? If I use the R indicator terminology, maybe I didn't say it, but a higher R indicator indicates that there's less variability in subgroup response rates. So if my adding of a phase increases the R indicator, I judge that my respondents are now closer to my sample, at least along those measured characteristics. So that's a proxy approach. But I think it's also interesting to know that those different protocols attract different persons, recruit different kinds of persons. If I never had a phase 2, I wouldn't know how that might differ from phase 1. But having had it now, I can at least say empirically what that difference was. And then often we can speculate about the differences of, is more reporting of some sensitive behavior, does that indicate that we're actually tapping into a group that has that sensitive behavior? So sometimes we can make those kind of judgments, but often we can't, and then we rely on proxy indicators.
Here's a question asking, this is a tricky one. How do you tell whether the differences between phases are from the mode that you're using in that phase, like versus something else, or due to differences between the subpopulations that respond to those different modes?
Yeah, that's a great question. So I might have glossed over that a little bit, to say, well, younger persons respond in phase 1, older persons respond in phase 2. Of course, it's never 100% black and white, as I seem to present it in that example. The differences between the phases, and generally what we do is, as you point out, in the first phase, we're offering a protocol, and then the non-respondents to that protocol are offered this phase, the second phase protocol. And as I said, overall, we want to judge the respondents against the sample. So when we combine those two phases together, we can compare them to the characteristics of the sample and say, has it drawn, after the second phase, has it drawn closer to the characteristics of the sample? So you can't say if I had have switched the phases, for instance, that I would have got the same result. So those kind of choices are often implicit, and I think someone alluded to a SMART trial where that sequence can often matter. That sequence can often be an important part of the experimental treatment. And I've glossed over that a little bit. I think in surveys, what people have generally done is to use phases to help control costs, and let's say implement low-cost phases early and high-cost phases later in the protocol. And in that way, you're reducing the overall cost of the survey. But the overall goal is to draw the respondent pool closer to the sample based on the observed characteristics.
Yeah. Now, if you're going into the survey and you don't know exactly what the sample looks like, that could be more challenging to judge whether you're getting closer or moving further away. It's an unknown target.
Sure, and I'll give you kind of an example. We used to do a lot of telephone sampling, not so much anymore. We called it random digit dialing. So we would randomly generate phone numbers out of banks that we knew to be assigned residential numbers. What do you know about a telephone number? Well, usually you don't know much at all, and particularly now that people have moved to cell phones, you don't even know exactly where they live because the area code isn't geographically tied in the way that it used to be. what we used to do so there's some sampling frames that aren't going to allow you to do much because you won't know much about your sample. You won't have many observed characteristics. But even in those cases, what we've managed to do is to merge on information from other sources to say, is this a listed number? Is this a number we believe to be located in a geography? What are the characteristics of that geographic area? To try and develop information that's going to allow us to assess, is our sample and our respondent set close together, at least along those measures that we're able to assemble. I don't know all sampling frames, but I imagine there are some where you have very little information like that RDD sample, and it's very difficult to add information, and you're just limited in what you can do, and that sometimes that's just the case.
So you work at one of the leading survey research centers in the world, and you've got access to all sorts of resources and colleagues. There are lots of other people listening to this webinar who don't have those resources, don't work in that environment. How can they learn more about this? If they're intrigued by what they're hearing today, where can they go to get more information? Or are there courses? Are there more extensive webinars? Where can they pick up more information?
Yeah, thanks for asking that question. I think I showed our website earlier. We run a series of webinars essentially on this topic. And I want to come back to the first part of the question was, we're a highly technologized survey center with many professionals who develop our systems and are trained to use those systems and so forth. One of our main goals over the last few years has been to essentially proselytize our techniques and help people bring these techniques to low technology surveys. We think it's important enough that we've spent a lot of time developing tools that we try to pass along, whether it's a checklist, whether it's methods for collecting and storing data about data collection to help people implement these procedures. And so I think if you go to our website, you'll find a lot of those tools. I don't know if I can... Okay, put it at the very beginning of the slides. I'll go back. Don't look while I'm flipping slides there. The website at the bottom of this slide, we have a bibliography section. We have I think a tools section where we keep a checklist. I think we have some examples of how data might be stored and that sort of thing. And information about our webinars, of course, is also at that website. So I think that's a pretty good place to start.
Thank you. Here's a technical question. So you're collecting data in these different phases, often with different modes. Are there weights that come into play when you're putting the data together to analyze them? I'm not sure how that would work in this context.
Yeah, thanks. That's a great question. I sometimes say this is the fifth beetle of responsive survey design, or the unknown beetle, the little researched area. Pete Best was the fifth beetle, by the way. The idea is combining across multiple phases might require special techniques for analysis. The only thing that I know of is if you have done any sampling along the way. So for instance, if at the end of phase one, I have 100 cases left and I draw a sample from those 100 cases, I draw a sample of 50. Well, now I'm creating a sampling situation that's going to require some weights. And I'm going to need those weights to carry forward in the analysis to reflect the fact that I did that sampling. Other than that, we haven't really found special procedures that are needed for analysis, other than those kind of weighting steps that might be needed if you did some sampling along the way. It's a special area within survey sampling that dates back to the 1940s. People at the Census Bureau started talking about two-phase sampling, which is what they labeled this technique. And I think our website will direct you to more resources on that topic as well.
All right, a final question for now, though I definitely have not gotten through all the questions that have come in. Mm-hmm. So somebody's working up a grant application. They're proposing to use the sort of methods that you're describing. In your experience, how is that received at NIH study sections? Sometimes study sections are not very friendly to methods that aren't well established and have a long history. Have you all had difficulty, or are you familiar with others that have proposed projects using this methodology? Has that gotten through study section without too much of a fight?
It's a harder question to answer. So the kind of research that I do is methodological, and so we've been running a lot of grants. We write a lot of grants that are designed to help us do research in this area. So, for instance, we're investigating Bayesian versions of rules to implement. In terms of other people using this as part of their grants, I know from my own experience when we write proposals for potential federal statistical clients, they've often asked us to include plans for responsive or adaptive design. I just got one this morning for a major survey that said, please tell us how you're going to use responsive design in this major federal survey. If I was writing a grant, I would highlight it, I would cite the sources, and I would say these are major federal surveys that use these techniques to ensure the quality of what they're doing, and I want to use them here.
Okay. I'm afraid we have run out of time. It is the top of the hour. Let me turn back to Natasha to wrap up our session today.
Thank you, Dr. Murray, and thank you to everyone who participated in today's webinar. As I mentioned at the beginning of the webinar, we will be posting slides and a recording of today's session on our website next week. You will receive an email with a link to the recording when it is available. Thank you.